has been using with the power for the last 5,500 years, and repeatable sailboats and sailing ships. Windmills have been and using for irrigation, pumping and for milling grain since the century AD. In what is in the USA, the development of the water pumping windmill was the major factor in allowing the farming and ranching on vast areas. Otherwise, devoid and readily accessible water. Windfarms contribute and the expansion of rail transport system throughout the world by pumping water from weather wells in the streams, locomotives, and the multi-blade wind turbines, a totally tower made of wood or steel was for many years a fixture of landscape through rural in America. 150 with generators and batteries banks, small wind matchers provides electricity to slide farms.
Earth is unevenly heated by the sun, such that the poles receive less energy from the sun than the equator. Along with this, dry lands heats up and cool down more quickly than the seas do. The differential heating drives a global atmospheric convection system reaching from the Earth's surface to the stratosphere, which acts as a virtual ceiling. Most of the energy stored in these wind movements can be found at high altitudes where continuous wind speeds of over 160 km/h occur. Eventually, the wind energy is converted through friction into diffuse heat throughout the Earth's surface and the atmosphere. The total amount of economically extractable power available from the wind is considerably more than the present human power used from all sources. The most comprehensive study as of 2005 found the potential of wind power on a land and near shore to be 72 TW, equivalent to 54 million tons of equivalent per year, or over 5 times the world's current energy use in our forms.
Distribution of wind speed. The strength of wind varies and average value for a given location does not alone indicate the amount of energy a wind turbine probability distribution function is often fit to observed data. Different locations will have different wind speed distributions. The Weibull model closely mirrors the actual distribution of hourly wind speeds at many locations. The Weibull factor is often close to 2 and therefore a Rayleigh distribution can be used as a less accurate but simpler model because so much power is generated by higher wind speed. Most of the energy comes in short bursts. The 2002 Lee Ranch sample is telling. Half of the energy available arrived in just 15% of the operating time. The consequence is that wind energy from a particular turbine of wind farm does not have a constant and output a full fire power plant.
Electricity generation. In a wind farm, individual turbines are interconnected with a medium voltage power collection system and communications network. At a substation, this medium voltage electric current is increased in voltage with a transformer for connection to the high voltage electric power transmission system. The surplus power produced by domestic microgenerators can, in some jurisdictions, be fed into the network and sold to utility company, producing a retail credit for the microgenerators owners to offset their energy costs. Grid management. Induction generators, often used for wind power, require reactive power for excitation, so substations used in wind power collection systems include substantial capacitors, banks for power factor correction. Different types of wind turbine generators behave differently during transmission grid disturbances. So, extensive modeling of the dynamic electromechanical characteristics of new wind farm is required by transmission system operators to ensure predictable, stable behavior during system faults. In particular, induction generators cannot support the system voltage during fault. Unlike steam or hydro-turbine-driven synchronous generators, double-fed machines generally have more desirable properties for grid interconnection. Transmission systems operators will supply a wind farm developer with a grid code to specify the requirements for interconnection to the transmission grid. This will include power factor, constancy to frequency, and dynamic behavior of the wind farm turbines during a system fault.
A wind farm is a group of wind turbines in the same location used for production of electric power. A large wind farm may consist of several hundred individual wind turbines and cover an extended area of hundreds of square miles. Both the land between the turbines may be used for agricultural or other purposes. A wind farm may also be located offshore. Many of the larger operational onshore wind farms are located in the USA. As of November 2010, the Roscoe Wind Farm is the largest onshore wind farm in the world, 5 megawatts, followed by the Horse Hollow Wind Energy Center. The Thanet Wind Farm in the UK is the largest offshore wind farm in the world with 300 megawatts, followed by Ons Rev in Denmark. Offshore wind power refers to the construction of wind farms in bodies of water to generate electricity from wind. Better wind speeds are available offshore compared to on land, so offshore wind power's contribution in terms of electricity supply is higher. Siemens and Vestas are the leading turbine suppliers of offshore wind power. DONG Energy, Vattenfall, and E&ON are the leading offshore operations. As of October, 3.16 gigawatts offshore wind power capacity was operational, mainly in North Europe. According to BTM Consult, more than 16 gigawatts of additional capacity will be installed before the end of 2014, and the UK and Germany will become two leading markets. Offshore wind power capacity is expected to reach a total of 75 gigawatts worldwide to 2020 years, with significant contribution from China and the USA.